All right, let's talk a little bit about some measurements and the box model. In CSS, you use measurements a lot. Margin, padding, font size, width, height, etc. All use measurements to determine the size of a specific value. For example, in this selector here, we have the level 1 heading being selected, and we have a series of styles. So we have font size that has 2.4 rem, width is 50%, padding 2em, margin 10 pixels. So all of these are using measurements. Here's a quick table of the most common measurements used in CSS. So we have the pixel unit, we have the percent unit, we have the em unit, and em, just so you know, is relative to the font size of the parent element. So if the parent element has a font size of 14 pixels, then 1em is equal to 14 pixels. So it's kind of like math. If you were to say 2em, then that would be 28 pixels, and so on and so forth. So that you'd use that if you wanted to style, use a size relative to its parent. And the rem is relative to the font size of the root element or the HTML element. So if you styled the HTML element to have a font size of 18 pixels, then 1 rem is 18 pixels. So the CSS box model, think of all elements in HTML as appearing within a box in the layout of a page. CSS treats all elements this way. Both block and inline level elements occupy a box. All boxes have a margin, padding, and borders. Block level elements have a width property, whereas inline level elements do not. Here's a visual example of the CSS box model. So we have in the center the content area. This would be the element itself. Let's just say a div tag. It has a width, and then outside of that dotted line you have padding, and then you have a border, and then the margin outside of the box. Margins live outside the box, like I just said, and in the example the margin has a dashed line around it just to show the area that it resides in. In the browser, margins are totally invisible. You cannot see them. There's no borders or anything around them. Top and bottom margins overlap on adjacent elements. So if you have a level 3 heading followed by a level 4 heading, and you've defined the H3 to have a margin bottom of 30 pixels, and the H4 to have a margin top of 10 pixels, you might think that this adds to 40 pixels, but it doesn't. The two margins, they overlap, and the larger of the two margins are used. Therefore, the margin between the two elements would be 30 pixels. Here's an example of exactly what I just said. So on the left side of the screen here, you'd think that this would happen. The level 3 heading has 30 pixel bottom margin, and the level 4 heading has a 10 pixel top margin. You'd think that they would sit on top of each other like so, and adding up to 40 pixels of total margin. However, on the right side of the screen, this is actually what happens. The smallest margin is absorbed into the larger margin, so there's really only 30 pixels in between the two. Now, keep in mind, this only happens on top and bottom margins, not left and right margins. Inline elements and margins, how does it work? Well, inline elements do not display vertical margins. They don't have top and bottom margins. However, they do display left and right margins. Padding resides within the box, so you can see in the example that the background color is the same in the content area as it is in the padding. In order to add margin and padding in CSS, all you have to do is define the size of the margin on all 4 sides of the box. Here's an example. Margin top, right, bottom, and left. They all have 10 pixels of margin. Note that all 4 values consist of a measurement of 10 in that previous example, and a unit, pixel, with no spaces between them. In the previous example, we declared all sides of the box to have the same values. Instead of writing it like we just did, we can write the previous example in a much simpler way. Because they're all equal and they're all using the same unit, we could just say margin 10 pixels. And the browser would treat that as all sides having 10 pixels of margin. If any of the values are equal to 0 pixels, we can skip writing the unit like so. And this applies to more than just margin and padding. Anything that's using a measurement. If it's equal to 0 pixels, ems, or anything like that, you just put 0. Another way of writing our margins and padding more efficiently is like so. Margin 0, 10, 20, and 30 pixels. Just remember the order of the values. This is always the case when you're talking about margin and padding or the box model. So the first value is top, and then right, and then bottom, and then left. Essentially, you could think of it as going clockwise. In some cases, you can use two values. So in this example, we have 0 and 10. The first value is equal to the top and bottom, and the second is the left and the right. And you can also use three values. So in this case, we have margin 0, 10, and 20. This means that the top is 0, the left and right are equal to 10, and the bottom is equal to 20. All of the previous techniques apply to defining padding and borders as well. Borders are a little bit different, however. Borders don't only have a border width. They also have a border style property and a border color property. Only the border style property is required. Here's how you can declare them in CSS. Border style, and in this case we can choose, say, solid. Border width, 4 pixels. Border color, 333, which is a dark gray. What if all sides have the same style, width, and color? Well, there's a shorthand for that too. You could just say border, solid, 4 pixels, and this specific HTML code. You can also create variations in the border properties by overriding some properties with more specific declarations. So border, solid, 4 pixel, 333. This will mean all the sides will have this style. However, you can override the border bottom color and change the border bottom color to a lighter color, or whatever color you want. Since the second border declaration comes later in the style sheet than the first declaration, the CSS overrides the bottom border color of 333 with FC3 instead. Okay, that's it right now for the measurements and box model. We will be jumping into actually coding and doing this stuff for real, but first I just want to get a little bit of theory out of the way.